every morning with drive. Being on the grind, know I had to survive. We had to win. Started from the dirt and the rubble. I had to be the needle that was popping your bubble.
Hello and welcome into the Rookie Prospect Profile Series, a Zilla Fantasy Elite production. Today we're going to be looking at running back Roschon Johnson. Roschon Johnson was drafted number 115 overall by the Chicago Bears, and they come into the league out of Texas University as a Longhorn there. Looking at some of their physical traits, we can see that Roschon Johnson comes in at 6 foot, 219 pounds, the BMI of 29.7. Looking at their 40 score, it is 4.58, which gives us an overall speed score of 99.5. Putting their physical traits along with some of their college numbers into the RStudio model, we get a prospect score of 12.464 for Mr. Roschon Johnson, which ranks number 174 overall. Out of the 310 running backs in the RStudio Models database. That's a 43rd percentile, almost 44th percentile within that database. And then shifting over to see who are the closest comparables to Roschon Johnson's 12.464 prospect score, we see that the next closest better than him is actually James Robinson. A couple higher than that, or next higher than that, Devontae Booker, Tony Pollard, Jonathan Grimes, Cameron Artis-Payne. And then the next closest below him, Kyle Juszczyk, James White, Wayne Gallman, Lamichael Pirine, and Fred Jackson. A couple people in there, pretty good. Tony Pollard, James Robinson, James White, Fred Jackson. A lot of people in that particular area, pretty successful. So we'll remain to see if Roschon Johnson ends up being a James Robinson, Fred Jackson, Tony Pollard level of producer. James White in there as well, or if it's more of a Wayne Gallman, Lamichael Pirine, Cameron Artis-Payne type of production out of him. That's the RStudio model. Switching now to the machine learning model for Roschon Johnson, we can see that he comes in with a mean of 10.29, a median of 10.14. Their minimum prediction is 6.48, and their maximum prediction is 13.96. Their 10th percentile outcome is 8.11. Their 25th percentile outcome, 8.96. 75th percentile outcome is 11.43, and their 90th percentile outcome at 12.73. And looking at their mid-50 gap, that was 2.48. Getting into the rankings for each of those numbers, we can see that the mean was 23, the median there at number 26. The minimum prediction there is 15th best overall, and the maximum prediction only at 30th best in the class here. Kind of getting into some of those other percentages, we see 19th, 22nd, 25th, 20th there in the percentile outcomes, and then number 10 overall there for the mid-50 gap, which isn't too bad. Switching gears back to the output there, the 10.29, 10.14 for the fantasy points per game. Best season according to what the neural network says. Again, we saw this similar to some others on here earlier, kind of Kendre Miller level, where 10.3 exactly for Mike Gillislee's best season. Donald Brown at 10. Tyler Algier last year at 9.96. Jalen Samuels, 9.9, Charkandrick West, 9.5, Rob Kelly, 9.5, Cam Akers there at 9.42. Give you a little level of what it looks like for Roschon Johnson's best season on average, according to the model. Getting up into that 13.96, we did see that was the 30th ranked highest prediction in the model this year. So with that in mind, it might be a little bit interesting to delve into why that might be. Clearly the 13.96 there, the model just doesn't like Roschon Johnson's profile. We know he sat behind Bijan Robinson there at Texas for the last 3 years. So that could have something to do, with his college dominator rating being lower. I believe his college dominator rating was only 12.7%. He had a 6% target share. That's really numbers that the neural network took in and said, hey, this guy is likely not going to produce a high-end ceiling. But getting into that 13.96, almost 14. We're looking at Damian Harris, 14.01. Kerryon Johnson's best season was 13.9. Pierre Thomas, if you remember him back in the day, 13.89. Spencer Ware, 13.8. Clyde Edwards-Helaire so far, 13.54. Kenneth Walker, 13.51. And then getting a little above that 14 mark, as I said, Damian Harris, 14.01. Zach Stacy, 14.1. Miles Sanders, 14.2. Jay Ajayi, 14.4. Gibson, 14.44. Marlon Mack, 14.5. So that's kind of what it's telling us is Roschon Johnson's ceiling in his career is essentially a Miles Sanders level, Clyde Edwards-Helaire level type of, ceiling for Roschon Johnson. I think that feels probably about right for what he brings to the table. I don't think he has an elite ceiling, but there in Chicago, I think he could profile as somebody that takes quite a few touches there in that system and going to provide you probably somewhere in that 10, 11 point, 12 point range in terms of fantasy points per game as his best season. Should he get that volume there in the Chicago Bears offense. So hopefully this RStudio model and the machine learning model, both of these give you a little bit of additional confidence in all the analysis that you're doing for all of these incoming rookies. That's going to do it for today's rookie prospect profile on Roschon Johnson. This is presented by Zilla Fantasy Elite. Thanks for tuning in. Bye. As a reminder to how the machine learning model functions for those who have not caught it yet, a very broad overview. The model is training and validating and then going backwards to adjust the weights of each connection of each node in the network. It will do this 30 different times to get the closest predictions from the validation portion of the data. So to explain a little bit further or more in depth, the model will go through on the first epoch, again of 30, training on 80% of the data. It will then predict outcomes of the remaining 20% of the data called the validation set. It sees how close it was to each prediction, and then will go backwards through each connection to determine how much each connection provided to the error. It will then adjust the bad connections down in weight and boost the good connections up in weight. It will then start that second epoch, again of 30 total, with the brand new weights for each connection and train on the same 80% and make more predictions on the same 20%, that validation set. It then again goes backwards through each connection to adjust the weights. It does this 30 different times. Any more than that, and this particular network will start overfitting the data and becomes worse actually at predicting the outcomes. For reference, there are a total of 14,040 neural connections within this neural network model. At the very end of these 30 epochs, with the best weights at each neural connection, it will then make a prediction on the incoming prospect, given that prospect's own individual inputs. I have the model go through that entire process 100 different times, reshuffling the 80% training set and the 20% validation set for each of the 100 iterations. It makes 100 predictions in totality, and this is what is used for the mean, median, min, max, standard deviation, 10th, 25th, 75th, and 90th percentile outcomes, as well as that mid-50 gap or M50 gap, which is the gap between the 25th and 75th percentile outcomes. The larger the M50 gap, the more spread out the predictions were, and the more volatile the player outcomes can be considered should that prospect ever reach 80 opportunities in a season. The data the model is training on is any running back in the last 10 NFL seasons, so that's 2013 through 2022, that had at least 80 opportunities in one of those seasons. There are 20 different inputs into the model currently, and the output is that NFL player's career best season in fantasy points per game in a PPR setting. There are 243 total running backs with at least 80 combined targets and carries within the model.
Whole crew on top, really we on top. Wake up every morning with drive. Been on the grind, know I had to survive. We had to win. Started from the dirt and the rubble. I had to be the needle that was popping your bubble.